Good morning, everyone. So my name is Virginie Vasselin. So I'm from ANDRA, so the French Waste Management National Agency. And today I'm going to present the challenges we have in France to face for waste management, and also how we deal with the new nuclear program and the impact on our project and disposal which are in operation. So just to begin, so I want to remind you that in France we have three cornerstones of radioactive waste management. So we have legal requirements through different law. We had in the past from 1991 to 2006 on the management of radioactive waste and sustainable material. We have also a national plan, which is applicable to all the sectors in which radioactive waste are going to be produced. So this is important to have in mind because in France, also waste coming from defense sector are managed by ANDRA and by this national plan. And we have a specific national agency, which is a public body, which operates independently to waste producers. So ANDRA, so we are located in France in 5 sites. So we have 2 disposal in operation, so in east of France, I'm going to present to you. 1 underground research laboratory, so also in east of France, so in order to perform some research, so for the development of the project CGO, the Deep Geological Disposal. And we have 1 disposal which is already closed, so next to La Hague site, so in west of France, and our headquarters are in next to Paris, so in Châtenay-Malabry. We are around 700 employees in ANDRA. So ANDRA is in charge to develop and to operate disposal for radioactive materials. So radioactive waste, sorry. So radioactive waste or radioactive substances which cannot or will not be reused in the future. So it's important also to have in mind that because in ANDRA we are not in charge, to manage radioactive materials. And what are radioactive materials in France? Spent fuel, for example, because in most of the countries, spent fuel is considered as waste. It's not the case in France. We have a reprocessing plant. Also, depleted uranium or reprocessing uranium is considered as material and is not managed by France in storage. So, in France, we have a radioactive waste classification with categories, and so radioactive waste is classified according to how they are managed, based on the level of the activity and on the half-life of the main radionuclides which are in the waste. So due to that, we have some category coming from very low-level waste to high level, and from short-lived radioactive waste to long-lived radioactive waste. And for each of these categories, I'm going to present to you the disposal we have in operation or we develop. Also to mention that in this category, you can notice that we do not have in France clearance level, and it's why we have this disposal for very low-level waste. ANDRA is also in charge to implement the national inventory. So each year we provide a comprehensive annual overview of quantities of radioactive waste and materials, so in France. And every 5 years we have an exercise to estimate forecast quantities of waste and materials according to several scenarios, focusing on the future of nuclear facilities, but also on France's long-term energy policy. So to Well, this exercise is important for us also to anticipate the need of future disposal to manage this waste. So the result of the exercise in 2002 was that at the end of 2021, we had in France 1,700,000 cubic meter of radioactive waste produced in France. And main of this radioactive waste are coming from electronuclear industry, around 60%. So, regarding now the different categories we have to manage in France, so you can notice that the major part of the volume of the radioactive waste which is produced in France, so around 90% of the volume, is for a very small fraction of the radioactivity level. On the other side, more than 95% of the radioactivity is in a small fraction of the volume of the radioactive waste we have to manage in the country. And this is also due to our national policy in France, the reprocessing of spent fuel. So for each of these categories, so we have different disposals. So in operation, like for the very low level waste and the low intermediate level waste short-lived, and in project, so for the low level waste long-lived and intermediate level waste long-lived, high level waste. So I'm going to present this different disposal or project. So the very low level waste category, so the waste are primarily produced when you have operation of decommissioning in the nuclear facility. And as I said before, as we have no clearance level, so we produce during this decommissioning operation, so a lot of this waste, so very low level waste. These waste can be material, scrap metal, plastics, rubber, earth, and they are disposed of in a facility so opened in 2003. So the Industrial Facility for Nuclear Collection, Storage and Disposal, the CIRES. It has an authorized capacity of 650,000 cubic meter. And we have now an application for this, the increase of this capacity. And at the end of 2022, it was filled around 70%. So here you have some pictures of this facility. So on the corners, maybe. Okay. So on the right side of this slide, so you can see that the waste, so in drum or in big bag, are disposed of directly, so in the clay layer, which was digged, and afterwards, some gravels are added in order to fill the voids and to enhance the mechanical strength of the cover. Then a cover will be put on this vault. Here you have an example of a vault in operation and vault which have been closed, and so you have a geomembrane non-permeable one which is put on this vault in order to avoid the ingress of water. So we received in 2022, so 24,000 cubic meter on this of waste on this facility. What are the main challenges we faced in France with managing this very low level waste? So as I said before, so with decommissioning, we produce a lot of this radioactive waste as we have no clearance level. And so we are going to have an increase of this volume of waste in the future. So we have already performed some optimization of our facility. And due to that, we can increase the authorized, we can ask an increase of the authorized capacity for the same surface area, so in the disposal. So, there were also some studies in order to construct a new disposal facility. So because the facility with the increased authorized capacity will be filled in around 2040-45. And so we need another disposal. And also we have, in the framework of the National Waste Management Plan, with the producers of waste, so some, discussions, some studies to perform in order to innovate and invest in the future, so for reducing the volume of the waste which are going to be produced by incineration, for example, for some. And also, there are some studies regarding the feasibility of a new disposal facility, so next to the near to the decommissioned sites, and because for the moment we have a centralized site, and we have now a new regulation for which we can study, so on a case-by-case basis, the recovery of metallic very low-level waste. And so it's also a study which is going to be done in the future with decontamination melting process. Regarding now the next category with short-lived, low and intermediate level waste. So main of this waste are coming from reactors, so operations or maintenance, or in this category you have waste like ion exchange resins, for example, filter resin, but also gloves, tools. And these wastes are disposed of in Centre de l'Aube since 1992. We have an authorized capacity of 1 million cubic meter of waste, and at the end of 2022, the capacity was filled around 37%. And so regarding the last exercise we made about the inventory, we expect the end of this disposal around 2070. So the waste are in metallic or concrete boxes, and they are put in some concrete vault. Afterwards, the vaults are filled with gravel or cement, depending on the type of package which are disposed of. And then these vaults are closed. With also a layer of cement and a bituminized layer in order to avoid the ingress of water. So here you have the both, so vaults which are closed and vaults which are in operation. And in 2022, so we received in Centre de l'Aube around 10,000 cubic meters of waste. Another category I'm going to mention is a long-lived, low-level waste. So this category is with mainly so waste which have been already produced, so in the past, for example, from the first generation of reactor in France, so the natural uranium graphite gas reactor, and they have produced graphite waste, which are in this category due to the content of carbon-14, for example. In this category, we have also radium-bearing waste coming from extracting rare earths from natural minerals, but also from zirconium production in order to produce the cladding for the fuel assembly. And we have other type of waste, like the residue from converting uranium facilities, so from Orano. And for this waste, we have a project so on which we work. It's what we call a shallow depth disposal. So it's a disposal which is 30-meter depth. So before I mentioned some disposal which are on the surface. So for this category of waste, we study a disposal at 30 meters of depth. And we have a site on which we make our study, Vendôme-Soulaine community, and which is in east of France. So we are at the beginning of the project. Regarding the last category, we have under the project of CGO. So we have waste coming from spent fuel reprocessing, so like fission products and minor actinides which are vitrified. And this waste are the category high-level waste, because as I said before, we have no spent fuel as waste, as considered as waste in France. The other part of the spent fuel assembly, like end caps and hulls, are compacted, so in La Hague, and put in a canister. You have a picture on the slide, and they are considered as intermediate level long-lived waste. And we have also in this category some waste produced by reactors or other facilities operation, like for example from reactor control roads. So due to the highly dangerous nature and long life of this waste, it cannot be managed at surface, so in the disposal I have presented before, so which are in operation. And so it's planned so to develop, we develop the CGO project, so the deep geological disposal. So the aim of this geological disposal is to protect the population, and the environment over the very long term without requiring human action. So it's why the facility is located at a deep level, so minus 500 meters. And it's located, it will be located in a clay layer, and this clay layer form a natural barrier because this clay layer is not permeable. So the principle of this disposal is to isolate the waste from the population and the environment. So for that, we have the depth of the disposal, and to contain the radioactive substances and limit their circulation. And for that, we have the properties of the geological clay, and also the properties of the packages. So we applied in January 2023 for the construction license. For a reference inventory of 73 1,000 cubic meter of intermediate level waste long-lived. Around 60% of this waste have already been produced, and the other are the forecast for the next years. And the reference inventory is also for 10 cubic meter, 1,000 cubic meter of high-level waste, so vitrified waste in our case, and approximately 40% already exists. You have here, well, a presentation of the planned CGO facility. So here you have the ramp, which for in order to move the well, the packages to the dispatch zone, and then from this dispatch zone, so the package can move to the intermediate level waste long-lived zone, in which so concrete boxes in which primary canister are put or disposed of, or through the high-level zone in which so steel canister will be disposed of in such a gallery, and vitrified waste canisters so are put in this steel canister. And here you have the shafts for ventilation, for example. What I want also to mention is that in the application we submit so this year to the Nuclear Safety Authority, we have an adaptability study in this. What is an adaptability study? It's in the future, if there is a change in the energy policy, and if we have no more reprocessing operation, in this case, we will have to manage spent fuel in the disposal. And due to that, we have to prove to the Nuclear Safety Authority that we don't need to build a new disposal. For example, we have to prove that you can imagine that a vitrified waste canister is more or less like that for the haze. For fuel assembly, so the length is higher, and we have to prove, for example, that we can use the ramp and the dispatch zone in order to manage this higher package. So it's why we have this adaptability study. So we hope to have the license in 2027 and to start what is called the pilot industrial phase in around 2035. 2040, and at the moment, with well, the schedule, it planned to close the facility in 2150. Now I have a few words about the challenges so linked to the new EPR2 reactors program, because when we start our CGO project application, it was not planned yet to build this EPR2 facilities, and so due to that, the French Ministry for the Ecological Transition mandated ANDRA with studying a waste management solution for the potential construction of 6 EPR2 as a basis for the government decision. So before taking the decision. So, regarding the waste, so the very low level waste and the low level short-lived waste, the waste which are going to be produced by the new EPR2 are going to have the same radiological and physico-chemical properties than those we already manage in our disposal. So, due to that, we have no issue regarding the type of waste. Regarding now the capacity, So as I said in the presentation of the different disposal in operation, we will need in the future some new capacity. And so further to the study, what we see is that the need to renew the disposal capacity for Cires and Centre de l'Aube will be deferred only by a few months with this waste coming from this 6 EPR2. Regarding now the project CGO, as for very low-level waste or low-level short-lived, the radiological and physico-chemical properties of the waste which are going to be produced are identical to those current waste produced. And so from this part, we have also no issue. In the future, we can have a different reprocessing strategy, mono recycling of fuel or multi-recycling of fuel. And so we have assessed both. And according to this strategy, we can have an increase of the volume of the inventory of high-level waste between 10 and 20%, and for intermediate level waste long-lived, around 5%. If reprocessing ceases in the future, as I said before, we have these adaptability studies, and so what we have assessed is that for spent fuel, so total activity and residual heat remain similar to those considered already in this adaptability studies. So we have also not detect issues with this type of fuel. If reprocessing continues or ceases, of course, what we are going to have is an impact on the facility of the life cycle of this facility and the surface area of the disposal zone, because we are going to produce more waste. But without any issue for the project. Just to finish, I want to mention also another part of our work in ANDRA. So we have initiated also discussion on SMR, AMR waste, so with startups and in order to, well, as you said, so in France, we have in our energy policy line, some well, SMR or AMR will be launched. And due to that, we have initiated exchanges in order to discuss about the type of waste they are going to produce, because there are some technologies that we do not have in France for the moment, like, for example, HTR technology with lead as coolant, or with triso fuel particle, for example. And so we have some exchanges in order to identify a suitable management solution for this radioactive waste. Of course, we are at early step because they are only develop their project. So it's all I wanted to say today. Please, if you want, come and visit us so on the stand, which is O54. And this afternoon, there will be a presentation of our expertise in support foreign radioactive waste management program, and also a presentation of CGO. Thank you for your attention.